In this session, we are going to introduce some basics of statistics, as well as introducing you all to the statistics before we start any probability, anything on probabilities. First, when I say statistics, what exactly triggers in everybody's mind? So you might have seen your daily newspapers where people talk about how much pollution is there in northern central part of India, like Delhi, and what is the percentage of carbon content in that. And also you see that how many people, and also coming to the sports, you might have seen that how IPL is going on nowadays, and how many runs that particular batter is doing. So all these numbers, okay, actually shown that who is performing better. Or if I take an example of one batsman, how his record has been from past several years, how many runs he made, what is the average he made, and what is the best he made, I mean to the maximum runs he made. So all these things, actually all these measures generally describe the data or the performance of that particular batsman, or anything, the situation or the scenario that you are expressing in the form of data. From that data, you are actually trying to tell some numbers out of it. Let us look at this example. An university is actually trying to show that who are the people who are graduating into chemical engineering, and there are many graduate engineering graduates are there, out of which how many of them are chemical engineers in 1998 and in 1988. So if you look at this one, from within 10 years, 1988 to 1998, what is the ratio of these chemical engineering graduates are changing? For example, here in 1988, if there are total graduates are 140, out of which 120 of them are chemical engineering graduates. Now in 1998, there are, let us say, 130 engineering graduates, out of which only 90 of them are chemical engineering graduates. So now, what this chart will give you, what is this actually talking about? This is actually talking about the data of engineering graduates, out of which how many of them are chemical engineering graduates. So you are representing the complete data in the form of simple charts or simple measures. Here it is just in a number. Okay, based on that you are actually describing the data. Let us talk about this figure 2. Here, what exactly this is representing? It is representing that you are having some stock price of Facebook, all right, and how it is varying from 2009 to 2018. And since we are in the year of 2016, it is projecting that is the projected stock price, okay, projecting the stock price in 2017 and 2018. So for example, if a person is at this time instant, let us say 2013, he has the history of the data 2009 until 2013, and he is projecting this data, means projecting the sales or the stock prices, okay, in the future years. So I'm not going to talk about how Facebook is performing and all these things, but this is an example I'm just taking to explain you that what anybody expects out of the data in the simple charts to describe about statistics of the data. So in this session I'm going to talk about more about descriptive statistics. Okay, descriptive statistics is the term given to the analysis of data that helps to describe or to summarize, okay, in a meaningful way. For example, if I'm giving you this particular sheet of data, Excel sheet of data, and I would ask you that what exactly this data is representing. Okay, so for an analyst, okay, who is going to sit down and looking at this data, he will first try to understand what is this data all about, And when he is going to communicate, he would actually start analyzing this data in this way. For example, if I'm looking at population projection of Delhi, okay, so this is a year, okay, and these are the, as of 1st March, okay, these are the males, these are the females, and urban, rural, as in 1st July, similarly the values. So as in 1st October, this is the value. If somebody comes and asks you about this data, forget about statistics. If somebody comes and asks you about the data, the first and very important uh, point, a very important way to describe this data is, hey, this data is talking about the number of males, females, okay, in urban and rural areas. They have recorded in 1st March of every year starting from 2002 to 2026, okay. Since we are in the year of 2016, these are all the projected values, okay. That is what the population projection of Delhi. So we are actually trying to predict what could be the population in Delhi. I don't know how they have predicting and everything, but this is the data I got it from the survey department. Now I will have to give some kind of summary of this data. So whenever you are trying to give the summary of this data, then you have to then that particular field is called descriptive statistics, okay. As I mentioned earlier, descriptive statistics is the term given to the analysis of the data. So you are going to do the analysis of the data, and here you are not going to do any projections or any predictions, any estimations. No, you are just, you got the data, you are actually giving the summary of the data. So now it is very important because you are going to take the raw data. This is called raw data. What I mean by raw data is that which is in the very basic form. No analysis has been done. No pre-processing has been done. What I mean by pre-processing, most of the data that we get out of all these surveys or any kind of experiments, the data will contain a lot of unnecessary information, that is called noise. So when we have this noise, okay, so before we conduct any analysis, we try to remove that noise. But here the question comes, how do I discover that noise? That I'm going to cover in the later sections. But to explain you that what is raw data is the data that you are getting in the very basic format on which you are going to perform some analysis, okay, and to describe the complete data in a very descriptive format. Is that clear? So now, in simple sentence, if anybody asks us what is descriptive statistics, which means that descriptive statistics enables us to present the data in a more meaningful way. Okay, in the simple way, I can say it is a simple interpretation of the data. All right. So simple interpretation, just now the way we have done here, this data is actually explaining about the population data, population projection of Delhi from 2002 to 2016-26, okay, and on March 1st, 1st July and October, okay. So now similarly, yes, if I talk about this particular table, okay, can somebody interpret this data by yourself? Please look at this table and try to see that what exactly can you interpret here. Yes, if we interpret this data, okay, this data is talking about near about 22 languages, okay, and people who are actually talking, of course the table title itself is showing, but let us only from the data itself, let us interpret this data. And okay, in 2001 and 1991, how many people are speaking Assamese in 1991 and in 2001? Okay, male, female, and the percentage it is showing, right? So now this is simple what the data is. Now I'm going to ask you that what is the percentage of the people who are speaking Hindi, okay, and those are males? Another question, how many people who are speaking Manipur, okay, who are females in 2001? And I also asked the questions that from 1991 to 2001, what is the percentage growth of people who are speaking Bengali in Delhi? Are you getting my questions? So all these questions can be answered from this data only. But in order to answer all these questions, first of all, we have to do a very simple operations on the data, which means that so simple measures that we have to find out. For example, if I'm taking an example of Sachin Tendulkar, I would say Sachin Tendulkar is a very good batsman. He is maintaining a very good average. What do you mean by average? The average is a simple measure that is completely describing his performance from the past 10 to 15 years. Similarly, if I say that one particular simple, what is that simple measure that I can get out of this data to explain, to interpret this data in a more meaningful way? That is what we are actually talking about, the descriptive statistics here, right? So the questions that I have asked, for example, what is the percentage of growth of the people who are speaking in Bengali from 1991 to 2001? Those are especially females. If I am asking this question, then I will go to 1991 female, and in 1991 female who are speaking Bengali, and 2001 who are speaking Bengali. Then what is the percentage of growth? So the percentage of growth is nothing but the difference between these by the original. So that is one measure. Percentage of growth is one measure that gives you the complete understanding of the people who are speaking Bengali. But from this data, there can be many questions can come out of it. So let us represent all of them in a simple form, so that that particular form, it may be a visualization graph, a plot that can provide you the complete set of information. This slide is mainly talking about collecting the data, understanding the data, finding the useful information in the data, interpreting the data, and visualizing the data. So somebody has collected this data, okay, and we are trying to understand this data. And after understanding the data, we are trying to find out what is that useful information that is needed. So useful information means those are patterns in the data. There can be many patterns. There you can retrieve many information out of it. I mean, it's many information points out of it. But from the business point of view, if a person asks a question from the business question, how do you really interpret it, find out that pattern? The pattern may be, I wanted to know the people who are, okay, this is the question perhaps I can ask you. I wanted to know how many people are there from South India. Okay, so South India, here in this data, South India is not well defined, but that is the question I'm asking you. So you know some of the South Indian places, and you know some of the South Indian languages. So you filter out those languages, okay, and then for example Tamil, Telugu, okay, and any other languages here you can see Malayalam, okay. So for example, some of these South Indian languages, I filter them out. After filter them out, I will call all these Telugu, Tamil, Malayalam or any other language into one particular bucket, and I would say that yes, these are all South Indian languages. How many of them are there? I filter out their information. So how do I represent that one in this very simple form? Okay, that means, see, it's not a pattern, but it's a kind of information that I'm trying to get out of this data based on the business question that was asked, right? So based on that business question, I found that information, and then I'm interpreting the data. Interpreting means I'm doing some operations on the data, and then show it in the same visualization format, maybe bar charts or simple linear charts. All right. So here, what I wanted to emphasize is that whenever you get this data that is in the raw data form, and you try to get all this raw data form into a very simple descriptive statistics form, or a simple measure like average or a percentage of growth or a maximum, minimum. So these are all some terms that generally people use to communicate or to interpret the data. Okay, so what is statistics? Okay, as I mentioned, that is an example here. Descriptive statistics means it's a collection, presentation, and description of sample data. So descriptive statistics are used by researchers to report on population and samples. Just now, that's what we have seen. And in sociology, right? And it is a kind of a tool that we use to comprehend the complete raw data in a more meaningful format. Okay, that is descriptive statistics. So you got the data and you're explaining about the data. Very simple. Okay, so what is inferential statistics? Inferential statistics are those from that data you make decisions, or you draw some kind of conclusions out of the data. For example, I'm going to the same data here. Okay, I was talking about number of people, maximum number of people, percentage of growth, and all these things. Now, suppose if I want to take a decision that as the population is increasing, right? That first of all, yes, whether the population is increasing, yes, it is increasing. That is a how do you know that population is increasing? That we can find out from the descriptive statistics using the univariate profiling. Number of males is increasing and females are increasing. Now the question I wanted to ask here is that suppose I want to take a decision that that is more relevant to female population. Okay, so now I'm going to take a decision. All right, first let me answer this question. Male is increasing the most or the female? Is it in urban or in rural? If it is in urban, what is the projected growth rate? If it is rural, what is the projection growth rate? So the questions that I'm asking, okay, those are all some kind of, I want to draw out some conclusions out of this data. I want to take some decisions out of this data. Should I focus more on the urban? Should I focus more on the rural? Okay, so the descriptive statistics just give you the information about the data, but inferential statistics is the one that helps you to infer something from the other. I want to infer that, okay, I will put it like this. So for example, in the rural area, okay, in the rural area, this is the population that is increasing. Okay, and this is the population of female, those are increasing. Okay, now I wanted to ask this question, as the female population is increasing, is it increasing at the faster growth than the male growth? I'm repeating my question again. The female growth rate, okay, I mean to say the projection, what it may be, is increasing much faster than this. Yes, I will answer that. Okay, in order to do that one, first we have to see the velocity of the population growth rate in each year. What I mean by velocity? Velocity is nothing but the number of population. For example, from 2016 it is 11,827. Okay, and 2015 of the same time. Okay, I'm calculating the velocity in 1 year. 11,827, okay, minus 11,481 by 1 year. Nothing but the difference. Okay, how much it is changing. Here, how much it is changing within the same year. 9,458 minus 9195. You can do simple math by yourself, okay, on a simple paper, and see that which one is increasing in 1 year. Now, if I ask the same question for the complete like this 2002 to 2026, you actually find out the difference between this and this and the number of years. Similarly, here, okay. So then you can easily answer that which one is actually growing at a faster rate. All right. So these are all some kind of I'm actually giving you some examples here. But what we are trying to achieve here is that to introduce all of you that from the data, okay, once you get the data that is in the raw data form, fortunately this data is very clean. What I mean by is that there are no missing values, okay, which has a very clean numbers. So we can we can actually describe about this data in the more descriptive form, okay. And if I want to draw out any conclusions or any kind of decisions, then I generally do some analysis that is called inferential statistics. That is what these are the two different segments, I would say two different segments that describes about statistics. Is it clear? Now, for example, from the industry standpoint of view, generally you might see sites, right? There you will find out different types of products and everything. But from the business point of view, let us say you are hired by one big e-commerce site where you are going to give some kind of suggestions to the management to take decisions, okay, in terms of revenue growth. Let us take this particular example, okay. Look at this particular page and there are 4 products, okay. Samsung Galaxy S3 Neo, that is blue and white, and there is Core 2 Samsung. So there are different products, and now everybody looks at these prices, EMI, and the specifications of these. So now the question here is that tomorrow, given the market changes, dynamics of the market, and as well what I mean by competitors and the product values, so how do I design, how do I come up with the optimal price, okay. How did they come up with the 7,180 instead of 7,200? How did they come up with this number? Why did they come up 12,480? So how do you decide, okay, the optimal price of these products, okay, so that your sales will be maximized?